So we set up the experiment, but how are we going to create a question, a hypothesis? How are we also going to predict what's going to happen to the eggs? So, what is happening inside of the eggs? Well, a phenomenon that's known as osmosis is occurring, and osmosis basically tracks the movement of water across a semi-permeable membrane. And what does semi-permeable mean? It means a membrane that allows some things to go through, but not everything. On average, a raw egg is 90% water and 10 to 12% sugar or protein. Since our egg's shell is dissolved, let's just focus on the two membranes that we see in our naked egg. We are going to model osmosis. Blue dots represent water, and the red dots are going to represent sugar or some kind of dissolved particle. So in our eggs, we start off with 9 water particles and 1 sugar to represent the 90% water and 10% sugar. And we are going to place this egg in a solution that has the same concentration of sugar. When we put the egg in the same solution, the rate of water leaving the egg is equal to the rate of water coming into the egg. Since both of those rates are the same, the egg will not gain or lose mass, nor will it shrink or increase in size. We would call this solution an isotonic solution, and if we were to focus on that prefix iso, it means the same. So basically, solutions with the same concentration don't have a change in mass. What if we place the egg in a solution that has more sugar than 10% and less water than 90%? So we have less water outside of the egg and more water inside. Water always moves from regions of high concentration to low concentration. So we would expect the water to move out of the egg, and consequently the egg would lose mass and shrink in size. This type of solution would be called a hypertonic solution, and the prefix hyper means more. This is a bit of a head scratcher because you might be wondering, how are you going to name a solution hypertonic when you actually have less water than what's inside? So solutions are named after the amount or concentration of the solutes or the dissolved particles. So sugar in our case would be the solute. However, osmosis talks about the movement of water, which is the dissolver or solvent. So it's a little bit counterintuitive because the solution's named after what doesn't move. So let's look at a visual example of this. Inside of the cell, we have more water and less sugar, but in the outside solution, you actually have less water and more sugar. So we would consider this to be a hypertonic solution. Now, what if we put the egg in a solution that has more water than the egg itself? So we're actually going to model putting the egg into distilled water, which is 100% water and 0% sugar. So I'm going to remove all of the sugar particles from this solution, the scenario right here. So in that case, remember, keeping our principle in mind that water is moving from high to low, there's more water outside of the egg and less inside, so you're going to imagine that the water will move inward. In this case, we are expecting that the egg will gain in mass and size. And we would call this type of solution a hypotonic solution. So hypotonic means less of, and in this case, it's referring to less sugar outside of the egg.